Who's sick of triangle proofs? If you're sick of triangle proofs, say aye. I don't hear anyone saying aye. All right, so no one's sick of triangle proofs, so let's do some more. In all honesty, this is the last section in chapter 3. So we're going to kind of wrap everything up about triangle proofs today. Then we'll take the test on it. And then when we move on to chapter 4, we're going to take a break from proofs for a little while. So 3.7 is more about triangle proofs. So to prove angles or sides are congruent, just like we did in the last section, the first thing that we're going to have to do is prove the triangle's congruent. Then we're going to state the angles or the sides that are congruent because of CP/CTC. Okay, we did that yesterday. So what we're going to add today is if you want to prove that something is a midpoint or something bisects, you might have an angle bisector or a line segment bisector. If you want to prove that something is perpendicular or parallel, again, we're going to have to first prove that triangles are congruent. We're going to again have to use CP/CTC to state any necessary sides or angles that are congruent, and then state what you're trying to prove using definitions or angle congruency. Hey, again, you'll see what I mean by that when we get into the problems here. And overlapping triangles, you can separate the triangles. Also, you can use color. Color is sometimes very helpful. And you're going to use the reflexive property on any common side or angle. In the past, so far, we've only seen a common side. First proof that we're going to do, you're going to see a common angle. And then we'll prove the triangle's congruent. Okay, so here we go with example number 1. So we're given that AC equals EC and angle A equals angle E, and we want to prove that AD is congruent to EB. So when I look at that picture, AD is going to be part of this triangle that I'm going to highlight in brown here, and EB, you can see, is that side of that pink triangle there. So again, you can highlight them in color, or if you follow my yellow arrow down, you can see that I separated the two triangles here. Okay, so all I did was pull that brown triangle down to there, and the purple triangle, or pink triangle, whatever color you think it is, down to there. Okay, so again, to do my proof, I need statements and reasons. And no matter what, the first thing that's going inside my statements is my given. So I have AC is congruent to EC, and angle A is congruent to angle E. And again, the reason I know that they're true is because they are given. So I'm going to mark them off in both pictures, just so, again, because it's the first one that we're doing here. So AC is congruent to EC. So AC is the entire side of this brown triangle, and EC is the entire side of this pink triangle here. So that's this side and this side. Okay, and now I also know that angle A is congruent to angle E. So angle A is that angle there, or again in our bottom picture, it's that angle there. And for our other triangle, for our pink triangle, angle E is here, where angle E is there. Okay, and then you can notice down here that angle C is highlighted in red in both pictures. Okay, or if you come back up to this picture, those two triangles overlap at angle C. So what we're going to do is we're going to use the reflexive property on angle C. So this is the first time that you're seeing the reflexive property for an angle. So angle C is going to be congruent to angle C because of the reflexive property. Okay, and now, again, 2 arcs through there, you have an angle, a side, and an angle. So the two triangles are going to be congruent by angle, side, angle. So triangle ACD is congruent to triangle ECB, and that's because of angle, side, angle. But again, that wasn't what I was trying to prove. I wanted to prove that AD is congruent to EB, and I can do that now because those two sides correspond, which means that CP/CTC, corresponding parts of congruent triangles, are congruent. Okay, for number 2, you're told that triangle JKL is isosceles and that KX is congruent to LY, and we want to prove that triangle JXY is isosceles. So the first thing I'm going to do is I'm going to highlight in pink this triangle that I want to prove is isosceles. So I want to prove that JXY is isosceles. So remember what the definition of an isosceles triangle is. It has two congruent sides. So my goal is to prove that XJ is going to be congruent to YJ. Okay, two sides of that triangle will be congruent. If I can do that, then I'll be able to state that that triangle is isosceles. So in order to do that, I'm going to go back and I'm going to prove two triangles congruent. So the two triangles that I'm going to prove congruent, I'll highlight one in orange. I'm going to highlight this triangle here, and then I'm going to highlight, how about blue, this triangle here. So if I can prove my orange triangle congruent to my blue triangle, then I'll be able to say that these two sides are congruent by CPCTC, and then I'll be able to say that the triangle is isosceles. So again, let's do our statements and our reasons. First thing I have is triangle JKL is isosceles. Okay, and KX is congruent to LY. And the reason those things are true is because it's given. Okay, so the first thing I'm going to do is mark off in my picture KX and LY. So KX and LY are there. Okay, and now also I'm told that the triangle JKL is isosceles, and JKL, I'm going to just kind of highlight in black around the outside, is this big triangle on the outside. Okay, so JKL is isosceles. So the first thing that I'm going to do here is I'm going to say that this side is congruent to this side because, again, definition of an isosceles triangle. Two sides of an isosceles triangle are congruent. So we're going to have JK is congruent to JL. And again, that's because of the definition of an isosceles triangle. Okay, definition of an isosceles triangle. Again, you have two sides that are congruent. And let me use two hash marks on those because I already used one hash mark on the bottom. Okay, now that I know that those two sides are congruent, though, I can also tell you that angle K and angle L are going to be congruent. Okay, and that is not by definition of an isosceles triangle. Remember, an isosceles triangle is technically classified by sides. So its definition is that it has two congruent sides. Its definition is not that it has two congruent angles. But what I can say is if I know that the two sides of the triangle are congruent, that the angles opposite those congruent sides are congruent. So the reason angles opposite congruent sides are congruent. Okay, and now I have enough information to prove that the two triangles, the orange triangle and the blue triangle, are congruent. I have a side, I have an angle, and I have another side. So now I'm going to say that triangle JKX is congruent to triangle JYL. And again, that's going to be because of side, angle, side. Okay, but again, that's not what I wanted to prove. Okay, so again, I want to prove that JXY is isosceles. So again, our goal was to prove that these two things were congruent. I have not done that yet, but I can do that now because again, XJ is part of my orange triangle and YJ is part of my blue triangle. So I can now say XJ is congruent to YJ, and that is because CPCTC. Corresponding parts of congruent triangles are congruent. Now that I have that, I do have the two sides of the triangle congruent, so now I can go ahead and say that triangle JXY is isosceles. And again, why is that? Definition of an isosceles triangle. Okay, again, the definition is that it has two congruent sides. You just prove the two sides congruent. Okay, so for 3, we're given that D is the midpoint of BF, end of EC, and I want to prove that BC is parallel to EF. Okay, so I eventually want to prove that BC is parallel to EF. So if I'm going to do that, remember what you have to have in order to show that two lines are parallel. You can either have alternate interior angles that are congruent. You can have alternate exterior angles that are congruent. You can have corresponding angles that are congruent, or you can have interior angles on the same side of the transversal that are supplementary. I'm not even going to bother writing it because there's no way that's coming into play here. Okay, so if I want to prove that this is parallel to this, here's going to be my transversal there. Okay, so from this group right here, when I look at that picture and I look at the triangles, the angles that are inside the triangles that are related to those blue lines is this angle here and that angle there. So those are going to be alternate interior angles. So if I can show that angle C is congruent to angle E, then I'll be able to state that BC is congruent to EF because they're alternate interior angles. So my goal is to prove that angle E is congruent to angle C. Again, once I do that, then I'll be able to say that the two lines are going to be parallel. So in order to do that, again, to prove that E is congruent to C, let me erase some of this drawing on here so it's not so messy. So what I'm going to do is I'm going to prove the blue triangle on the bottom congruent to the purple triangle on the top. And if I can do that, then I'll be able to say that angle E is congruent to angle C by CPCTC, and then I'll be able to prove that they're congruent. So statements and reasons. Okay, so the first thing that I have is D is the midpoint of B, F, and E, C. And the reason I know that that's true is because it's given. So a midpoint is going to break a line segment into two congruent segments. So if it's going to break BF into two congruent segments, that means that BD is going to be congruent to DF. But it's also the midpoint of EC. So EC is getting broken into two congruent segments. So that means that ED is also going to be congruent to DC. So I'll say that in one step. Again, you could break it up into two steps if you want. So BD is congruent to DF, and ED is congruent to DC. That's a 2 still, not a 3 yet. And that's by definition of a midpoint. Okay, so now I have two sides that are congruent. So now I have nothing left in my given. So I'm going to have to come up with another way to prove something in those two triangles congruent. And how about this angle and this angle? Those are vertical angles. So vertical angles are going to be congruent. So angle BDC is going to be congruent to angle EDF. And that is because vertical angles are congruent. Okay, and now again, I can say that those two triangles are congruent. I have a side, an angle, and another side. So that's going to be because of side, angle, side. So triangle EDF is congruent to triangle BDC. And that's because of side, angle, side. Okay, again, that's not what I wanted to prove. I want to prove that the two lines are parallel. Again, to prove the two lines are parallel, I need to prove that angle E is congruent to angle C. Well, now that I have the two triangles congruent, I can finally say that angle E is going to be congruent to angle C because of CPCTC. Corresponding parts of congruent triangles are congruent. And now, finally, I can have my last statement that I actually want to prove here. BC is parallel to EF. And again, why is that? Because those are alternate interior angles. So alternate interior angles are congruent. And you've now shown what you needed to show. One more and then we're done for the day. So given that AB is congruent to AC and XB is congruent to XC, I want to prove that AX bisects angle BAC. Okay, so again, if I want to prove that AX bisects angle BAC, and that's going to be my AX that's going to bisect it, I have to prove that those two angles are congruent. So again, my goal is to show that angle BAX is congruent to angle XAC. Again, if I can show those two things are congruent, that would mean that AX bisects. So again, let me get rid of what I just drew on there. That was to help me figure out what I need to prove here. And now again, in order to do that, that angle BAX is part of this purple triangle here, and the XAC is part of this triangle here. So if I can prove those two triangles congruent, then I'll be able to use CPCTC to prove my goal angles congruent, and then I'll be able to say that AX bisects BAC. So statements and reasons. So AB is congruent to AC and XB is congruent to XC. And again, I know those are true because they were given. So AB is congruent to AC and XB is congruent to XC. Those are my givens. Okay, fairly simple to see what's going to happen next. They share a common side, AX. So let's say AX is congruent to AX because of the reflexive property. And now I have enough information to prove those two triangles congruent. I have a side, and another side. So triangle ABX is congruent to triangle AXC, and that's because of side, side, side. Now that I have the two triangles congruent, now I can say those two angles that we were talking about in the beginning are congruent because of CPCTC. So angle BAX is congruent to angle XAC because of CPCTC. Corresponding parts of congruent triangles are congruent. But now that I know that those two angles, are congruent, now I can show what I actually wanted to prove. So my last step, AX bisects angle BAC. And why is that? Definition of an angle bisector. Again, what is an angle bisector? An angle bisector cuts an angle into two congruent angles. And we have our two congruent angles there, so therefore we can say that AX bisects angle BAC.